Welcome to this video. In this video, we are talking about BIRCH. BIRCH is balanced iterative reducing and clustering using hierarchies. Before we get into BIRCH and what is BIRCH and what is BIRCH do, let's take some basic. Let's get a basic understanding on clusters and like data clustering and other data clustering programs, and why do we actually use like BIRCH, and like what is the advantage of using BIRCH, and like what is hierarchical clustering. Let's talk about that for a minute before we get into what is BIRCH. Like BIRCH is an unsupervised data mining algorithm used to perform a hierarchical clustering over a particular large data set. This is what basic function of BIRCH. This is why we use BIRCH. But cluster is a closely packed group. Let's talk about like cluster. Like cluster is a closely packed group. A collection of data objects that are similar to one another are treated collectively as a group. This is what the basic understanding of cluster. And data clustering is partitioning of data set into clusters. That is data clustering. Data clustering, the problems arises in data clustering are like data sets are sometimes too large to fit into main memory, and IO operations cost the most, and BIRCH offers IO cost, but BIRCH offers like IO cost linear in the size of the data set, and that is why we use like BIRCH. And other data clustering solutions exist other than BIRCH, and some are like probability based clustering algorithms like CoWeb and Classist, and distance based clustering algorithms like k-means, k-methods, and Clarence. Like those are like some data clustering algorithms. And what like the main advantage of BIRCH is that it is local in that each clustering decision is made without scanning all data points and currently existing clusters. And that is an advantage of BIRCH. It exploits the observation that data space is not usually uniformly occupied, and not every data point is equally important. That is one of the like the basic observation that make BIRCH is like not every data point is considered important in the clustering, and it makes full use of available memory to derive finest possible subclusters while minimizing IO cost. And that is one another advantage of like BIRCH. It is also an incremental method that does not require the whole dataset in advance. That is another advantage of BIRCH. And like let's talk about what is like the hierarchical clustering. The algorithm starts with single point clusters. Like every point in the dataset is considered as a cluster. That is what in this algorithm starts with. Then it groups the closest points into separate clusters and continues only one cluster remains. That is like basic understanding of hierarchical clustering. And let's get into what is BIRCH. Like clustering algorithms like k-means clustering do not perform clustering very efficiently. It is difficult to process large data set with a limited amount of resources like memory or a slower CPU. This is why we use BIRCH. Like I mentioned before, this is like what I mentioned before. BIRCH is designed for clustering large amount of numerical data, done by integration of hierarchical clustering and other clustering methods such as iterative partitioning. BIRCH introduces two features for this to do this, and it is clustering feature and clustering feature tree, which is a both very important concept in understanding BIRCH. And let's talk about what is clustering feature. Clustering feature, the BIRCH algorithm builds a clustering feature tree while scanning the dataset. Each entry in the clustering feature tree represents a cluster of objects and is characterized by triples n, ls, and cs, given that it is works in n d-dimensional data points in a cluster, xi of I 1, 2, 3, etc. to n. Cf vector of a cluster is defined as a triple. Like Cf is considered as a triple of n, ls, and ss. N is number of data points in the cluster, ls linear sum of the n data points, ss is square sum of n data points. And let's take about some basic measurements of clusters. Like given n is d-dimensional data points in a cluster, then the centroid, if xi where I is equal to 1 to 2 to n be the data points. The center of x0 is equal to sigma of I equal to 1 to n xi by n. The radius is root of sigma I to xi minus x0 of x0 square divided by n. The diameter is root of sum of sigma I to n sigma j to n xi minus xj of whole square divided by n minus 1. In this, n is the number of points in the cluster, xi is the ith point in the cluster, xi is considered the ith point of the cluster. CF tree. Let's talk about CF tree. It is used to summarize cluster representation. CF tree is a height balanced tree that stores the clustering feature for hierarchical clustering. CF tree contains two parameters, branching factor B and threshold T, which is very important, that will come to later. Each non-leaf node contains at most B non-leaf entries of the form CFI and child I, where child I points to the ith child node. A non-leaf node represents a cluster made up of all the subclusters represented by its entries. A leaf node contains at most L entries. Each of them form CFI, where I is equal to I to 1, I is equal to 1 to 2, 3, etc. is equal to 2L. CF tree, it also has two pointers, previous and next, which are used to chain all leaf nodes together for efficient scan. A leaf node also represents a cluster made up of all the subclusters represented by its entries, but all the entries in a leaf node must satisfy a threshold requirement with respect to a threshold value t. The diameter or the radius must be less than the threshold value t. The tree size is a function of t. Larger than t and smaller the tree. Larger the t, smaller the tree. And this is a example of how a CF tree that is looks like. This is an example of CF tree. In this figure, there is a root node containing CF1 cluster feature. Then it points to non-leaf node containing B entries, that is CF1, CF2, etc. to CFB. Then it points, each non-leaf node points to a leaf node containing L entries, each containing clustering features CF1, CF2, etc. to CFL. This is an example of CF tree. And let's talk about what is BIRCH algorithm. For Ti, like consider where Ti element of D, we determine the correct leaf node for Ti insertion. If the threshold condition, where we consider in this threshold condition, is sometimes the diameter of the cluster, which if either it will fit or not, is not violated, and add Ti to the cluster and update CF triple. Else, if room to insert it, then insert Ti as single cluster and update CF triple. Else, split the leaf node and redistribute CF feature. And this can be better understood with an example, which I will show you after this. This is an example of CF tree. Initially, we have L1, LN1, LN2, and LN3. LN1 contains subclusters 1, 2, and 3. Initially, they are denoted as blue in this, and then LN2 contains two subclusters, SC4 and SC5. Like LN1 contains SC1, SC2, and SC3, and LN2 contains SC4 and SC5, and LN3 contains SC6 and SC7. Consider a scenario that a new subcluster SE8, which is denoted in the yellow circle, and we can see in the figure that it is denoted at the yellow, and we can see SC6 is SC8 is closer to SC1, SC2, and SC3, so we insert SC8 into LN1 clusters, but we can set the threshold size at 2. Like if there is more than 2, it is like it won't stay like that, as we can see here. So LN1 contains now 4 subclusters, which is not possible. So the size of LN1 is too large to fit. So in this case, we split the LN into 2 subclusters. ln1 dash and ln1 double dash, as we can see in the second figure. Now ln1 contains sc8 and sc1, and ln1 double dash contains sc2 and sc3. And in BIRCH algorithm there are 4 phases that happens. First phase is scanning all data and build an in-memory SF tree using the given amount of memory and recycling space on disk. Phase 2 condenses into desirable length by building a small CF tree. Phase 3 is global clustering. Phase 4 is cluster refining. This is optional, and we require more passes over the data to refine the results. And let's take a deep dive into each phase. Phase 1 starts with initial threshold, scan the data and inserts points into the tree. If it runs out of memory before it finishes scanning the data, it increases the threshold value and rebuilds a new, smaller CF tree by reinserting leaf entries from older tree and then resuming the scanning of the data from the point at which it was interrupted. Good initial threshold is important but hard to figure out. Outliers removal when rebuilding a tree. Phase 2, which is an optional phase, which is a preparation phase for phase 3. Potentially there is a gap between phase size of phase 1 result and the input range of phase 3. It scans the leaf entries in initial CF tree to rebuild a smaller CF tree while removing more outliers and grouping crowded subclusters into larger ones. In phase 3, it uses a global or semi-global algorithm to cluster all leaf entries. Adapted agglomerative hierarchical clustering algorithm is applied directly to the subclusters represented by their CF vectors. Phase 4, which is again an optional phase, additional passes over the data to correct inaccuracies and refine clusters further. It uses centroid of the clusters produced by phase 3 as seed and redistributes the data points to its closest seed to obtain a set of new clusters. Converges to a minimum, no matter how many times it is repeated. Options of discarding outliers. And now let's talk about the pros and cons of BIRCH. And we talked about the advantages of BIRCH before ago, but this is like the main function like BIRCH. What makes BIRCH other than other clustering algorithms such as Clarence and K-means. BIRCH performs faster than existing algorithms like Clarence and K-means on large dataset. That is the main performance of BIRCH. Scans for data only once and is outliers better, superior to other algorithms in stability and scalability. These are the pros of BIRCH. Cons is like, since each node in CF tree can hold only limited number of entries due to size, a CF tree doesn't always respond to what user may consider a natural cluster. If the cluster are not in shape, it does not perform well because it uses the notion of radius or diameter to control the boundary of a cluster. And this is BIRCH, and thank you for listening to this. Thank you.